Hello. In this video, let us evaluate the postfix expression using a stack data structure. First of all, before going to the evaluation of postfix notation, let us have a glance on how the postfix expression looks like. Postfix is an alternative way to write arithmetic expression, which is also called as an infix notation. Postfix refers to the fact that the operator is at the end. Infix refers to the fact that the operator is in between operands. This is what the difference between the postfix expression and infix expression. In the postfix, the operator is at end, but in the infix expression, the operator will be between the operands. Let us have an example. If you observe this, it's a postfix expression. This is 2, 2 and plus. So 2 operands, then operator. And coming for the infix expression, it is 2 plus 2. The operator is there between the 2 operands. So this is the difference between infix notation and postfix notation. And coming for the advantages of the postfix notation, so you don't need the rules of precedence. Whereas if you go for the infix notation, we require the precedences for the operator. If you have more than one operator in the expression, we need to check the precedence first. So based on that priorities or the precedences, we need to evaluate the infix expression. But here there is no chance of checking the precedence. There is no need of checking the precedences here. And also obviously we don't also require right associativity or left associativity. Unless until we have the precedence, same precedence, then only we'll be going for this right associativity and left associativity. And also we don't need any parenthesis for as like in the infix notation. In the infix notation, if we have lowest priority has to be operated first, then we need to override that particular operation with overriding the parenthesis here. So these are what the advantages of postfix notation. Now let us go for how to evaluate the postfix expression manually. So going from left to right, if you see an operator, apply it to the previous 2 operands. Generally it will be numbers. So let us go for an example. If we consider this 2, 10, 4, star 5 division plus 9, 3 minus, it is an example for postfix expression. For this, the equivalent of infix notation will be 2 plus 10 star 5 by 5 minus 9 minus 3. So this is an equivalent infix notation for this postfix expression. If we see an operator, apply it to the previous 2 operands here. So here I'm having 2 operands and an operator here. So whenever an operator is there, perform this operator operation on these operands. This is what the evaluation of postfix expression. If we are going to go for this expression, if we calculate according to the priorities and associativity rules, we'll get the result as 4. Now let us go for the computer evaluation of postfix expression. So the steps for evaluation of postfix expression. So we need to go from left to right as like in the normal evaluation. And here also, if we see a number, put it onto the stack. If we see an operator, pop 2 elements from the stack, do the operation, and put the result back onto the stack. So the top number on the stack is the operand on the right. So if we go for an example, let us go for this example which we have taken in the previous slide. So this is what my postfix expression. So according to the steps which we have taken here, so it is 2 is an operand. So I'm pushing the 2 onto the stack. So now the stack element was there 2, which was there obviously on the top. So next I'm going to read the second symbol, that is what 10. So whenever I'm reading the second operand, again it is a number. So again I need to push that onto the stack. and again I am reading the next number. So 4, again 4 is also an operand, so again that also must be pushed onto the stack. So now the next symbol in my postfix expression is star, that is an operator. So if you see an operator, pop 2 numbers from the stack. This is what the rule according to this statement. So now star is there. So what I did here is I removed 10 and 4 from the stack, and I perform this multiplication operator on popped elements, that is 10 and 4. So if I am performing this multiplication on 10 and 4, 10 into 4, that is what, 40. So the result again I am pushed onto the stack. So now the stack elements are 40 and 2. And the next element in my postfix expression is 5. So again it is an operand. Again go for the same step. That is what I need to push onto the stack. And then again the next symbol is an operator. So again you perform deletion operation. That is what, pop operations for the first top elements. So 5 and 4. So I need to perform the division operation here. So I need to perform the division operation for 40 and 5. So 40 by 5, that is nothing but 8. Again read the next symbol, that is what, plus. So again it is an operator. So again I need to pop 2 elements, that is what, 8 and 2. And I need to perform this addition operation on this 8 and 2. If I am going to perform addition, 8 plus 2, the result is 10. So that result I am pushing onto the stack. And the next operator, the next element is again operand. So I am pushing onto the stack. And again the next element I am reading is again 3. So again this is also an operand. So again I am pushing that onto the stack. And the next symbol in my postfix expression is operator. So I need to pop again the 2 elements, that is what, 3 and 9. So again 3 and 9 I performed, and the difference between 9 and 3. So that is what, 6. Again the result I inserted onto the stack. And again the next symbol in my postfix expression is again minus. So again I need to perform the subtraction between the operands 10 and 6. The result will be 4. So this will be my final result here. So this is what the computer evaluation of postfix expression. So the result is only thing on the stack when done. So at the end only one operand will be there. So this will be considered as a final result here. A helpful observation in the postfix expression is when you convert between infix expression and postfix expression, the operands, that is numbers, are always in the same order. Let us have an observation. So this is what an infix expression, and this is what my output, that is what postfix expression. If we observe 2, 10, 4, 5, 9 and 3, all these are numbers, operands. All these operands are again coming in the same order. Of course there will be change in the positions of the operators. So the operators may be probably in different order. So this is what an observation. Thank you.